let's start. Today we are going to talk about the rest of our ladder that we had for first order differential equations, and we are at the very end steps. So we are just going to talk about linear differential equations, first order, and we will try to also generalize it for higher order differential equations. Then we will talk about numerical solutions of equations. Maybe not this week, I'm not sure about it, based on how fast we are developing our content. And then we will just need to finish everything and start slowly diving into second order differential equations and higher order differential equations. Okay. Let me start from here. First of all, if you see this kind of, this is not right, let me just change it. If you have a differential equation, okay, what we have been so far doing is that, okay, when we are dealing with a differential equation, we were asking ourselves, okay, what is the order of this, and what is that, what is that, what is that? We can also try to classify differential equations from another perspective. What is the perspective? What you're seeing here is actually a general form of nth order differential equation. You have an equation which involves maybe x, maybe y, and some higher order derivatives of this independent variable y. Okay, independent variable here is x. Anyhow, we can go with two different branches for this. First of them are nonlinear equations. Another part is actually linear equations. Okay. In this course, we are not going to talk about nonlinear equations in the general theory, story, and so on and so on. We will come back and touch to it a little bit from here and there. And you have already seen some nonlinear equation examples. Do you remember anything? They're just trying to understand it. So what is the point of it? If I write you the general form of a linear equation, it is going to be looking like this. For instance, let's write the ln of x. The nth derivative, n minus 1 x y to the power minus 1 plus up to a2x y double prime a1x y prime plus a0x y equal to, let's call this p of x. Okay, this is the general form of linear nth order differential equation, ordinary differential equation. What is the meaning of this? All of these coefficients for I from 0 up to n and p of x are functions of x. What do we mean by that? We mean that in this expression that you see here, appearing as coefficients of this derivatives of y, they're just functions of x and no y is appearing. Okay? We can reduce this into some simpler cases. What are these some simpler cases? One of the most simplest of cases is that all of these coefficients are going to be just constant numbers. Okay? Equation with constant coefficients. For instance, look at this. Y prime plus y equal to 0. I don't know. 2y double prime plus 3y equal to 1. What do you see here? Is this kind of equations coming in this form or not? And maybe coming before to that, I can also give some examples of non-constant equations. For instance, example. Look at this, for instance. X to the power of 2 y double prime plus xy prime plus y equal to 2. Okay? Y prime plus xy is equal to sine of x, for instance. Okay? What do you see here? Are they really coming in this general form of linear equations or not? You see, let's check it. First of all, if we look at this equation, what is our n here? 2. Which means, yes, 2, our higher order derivative. What about here? 1. Here n is equal to 1. Okay. So, we have almost this part of it. Okay, and not the rest. Yes, please.
Is it about y or the power of
x to the power of 2 y double prime plus xy prime plus y equal to 2.
The prime
And
power. Burada üstü mü yoksa türevi?
No, n here is the order of the derivative. Okay? The highest order of the derivative. Look at this. This n is just here. The term coming with the highest order derivative, right? We are just trying to understand what is the order of this differential equation. I'm asking you this question actually. This is the second order linear differential equation. Yes, please.
Orada ikinci yani n2 yazdığımız için üstü ikinci derece.
No. We have nothing to do with this x's. These are just coefficients. This can be 4 or any other number that you want. It doesn't matter. The important thing is that we look at the y's, okay? And the derivative of the y and the order of that derivative which is happening. Good? Okay. So, this is then coming in the form a2 of x y double prime plus a1 of x y prime plus a0 of x y equal to that b of x, okay? This is coming as our a2. a2 is here x to the power of 4. a1 is x. a0 is this constant 1. And b of x is this 2. Again a constant. What about this equation? This is a first order linear differential equation. Why it is linear? Because it is in this form. Or y prime and y are not multiplied to each other. Or y prime is not coming into the power of 2. Or we are not having any sine, cosine, or this kind of functions of y. Okay? We do not see, for instance, something sine of y prime plus sine of y and so on. In this linear cases, I'm just going to give you some example, but we have also seen this. Actually, when we were studying the case of pendulum, okay, if you remember the equation governing the pendulum, it was actually non-linear second order differential equation with the sine term, which we said that, okay, let's take this angle very small, so sine of y is equal to y, or sine of theta is equal to theta for the small angles. So what we can do is that we can turn that into a linear equation. Okay? Anyhow, so is it clear what is happening with linear equations?
The sum of for linear equations, there is no much work with the y itself. Like as we used to work with x and treat others as constant. Now
Yes.
we're working with y and treat others as constant.
We are not treating others as constant.
As stuff multiplied by y.
Yes. You see, if it comes in this form, this is a form, right? If an equation is going to come in this form, then it is a linear equation of first order. Let me also add here the first order. Not first order, nth order. Sorry. Yes, yeah. So we are not treating x and y fixed or independent from each other or this kind of things. You look at the formal structure of the equation. Look at the formal structure of this. Is it similar to something like this or not? Okay? And you see, you have this similarity. If this similarity is going to come, then you are saying that, okay, it is a linear equation of this form. Let's see some examples of nonlinear equations. Then I think it will be much more clear. You had another question, right?
Yeah, I wanted to
Please.
ask, is the e the power of y, is it linear or not?
No, it's not linear.
Alright, so it's like cosine y, it's not linear, and then it's not linear.
Anything that is going to come, anything that comes, for instance, y prime plus, as you said, e to the power of y. This is a nonlinear equation. Prime to the power of 2 plus y equal to 0. Okay? Again, this is a nonlinear equation because we have y prime to the power of 2. Or we have this y double prime plus sine of y equal to 0. Okay? This is again a nonlinear equation. X to the power of 4 double prime to the power of 2 plus xy y prime, let's say, equal to sine of x. This is again going to be a nonlinear one.
Why power is not linear?
Because you have sine of y. If sine of x is coming like this, then we have no problem with it. As long as they are functions of x. Okay? But when it is turning into a function of y, then this is introducing a nonlinearity in the form of our equation. Okay? So this is if we have here, just a second. If we have e to the power of x equal to 0, this is linear. This is linear. This is nonlinear. You see the difference? Because now this is a function of y, not a function of x. And if you write this, this is going to be y prime equal to minus e to the power of y, right? Or in this case, y prime equal to e to the power minus e to the power of x. Okay? So look at this. In the second one, here, in this case, y prime is equal to minus e to the power of x. What do we have? We have something looking very similar to this form. Our a1, all of this a2 up to an, they're 0. We do not have them. a1 of x is just a constant function, 1. a0 is the 0 function. And b of x is e to the power of minus x, a function of x. But here, if I write it like y prime equal to minus e to the power of y, then this right-hand side is not going to be a function of x, it's going to be a function of y. So it is not satisfying this general form of linear equations. So we just say that, okay, this is not a linear. This is also a nonlinear equation. This.
For example, for the last one, if I remove the power 2, then it becomes linear, right?
No, still no, because we have y times y prime here. These two are also multiplied to each other.
But like it's also have x, so when you write it like y divided by the dx, you can do the math.
Don't go to doing some math. Try to compare it with the definition. This is our definition, right? We need to use the definitions. Look at this. If this is a linear equation, then y double prime's coefficient function must be a function of x. Here, check, it is x to the power of 4. Y prime's coefficient must be a function of x. What is y prime's coefficient here? xy. Is it only a function of x? No, it is not. It also involves y, right? So, it is not looking like this. Okay? Because the coefficients of derivatives of y coefficients of derivatives of y, which come in power 1, all of them, must be functions of x.
So basically, if you have any kind of y,
Okay.
there's some kind of multiplier.
Okay.
Then it's not linear for this case.
If it is in this form, it is linear. If it is not in this form, it is not linear. You need to compare it with this form.
Okay.
If it is in this form linear, not in this form, it is not linear. It is not that complicated. Just you need to be able to make comparisons and try to understand, is your equation in this form or not? This is the crucial part. You need to be understanding, okay, what are the coefficients of y, y prime, y double prime, and maybe higher order equation, okay? That's all.
Question.
Please.
Just to ensure, y square is not linear, right?
Y squared, where?
Y square alone.
Here.
No. Another than them all. Y square alone. Is it linear or non-linear?
Do you asking something different?
Yeah.
Okay,
y
then let
square.
me not look at there because
Or
then
y square. Is
Okay.
it linear or non-linear?
y squared. This
Or
one?
It's not even from the equations that.
This is not even an equation. Y to the power of 2 what? Maybe y prime is equal to this?
Yeah, can be.
Again, it's not linear. Why? If it is linear, it must be in this form, right? What is the coefficient of y prime? 1. A function of x, a constant. A constant is also a function of x, anyhow. Okay? Check. What is the coefficient of y? 0. What is the function on the other hand side? This must be a function of x. Is this a function of x? It is y to the power of 2, right? So
So y square is same to y prime multiplied by y, both non-linear.
yes.
Alright, thank you.
If it is not in this form,
Can I ask something?
yes.
Let's assume that for the last one, let's modify
This one,
Yes.
Okay.
For example, can you erase the x?
yes.
If I write it down from the sonuna.
Okay, from
My plus x. Would it be linear or not?
you what?
Sonuna ise artı x yazsam.
Here.
Yok, sine değil.
Okay, plus x. Okay, let me.
And it will be linear. Now, if I write x like that, it won't be a complete coefficient. It's gonna be.
Is it like this? Just a second.
Yanlış söyledim, tamam. Y prime'in yanındaki x, orası yerine x olsa, sonra artı y eklersem, o zaman olur mu? Değil mi? Olur. Çünkü coefficient değil.
Now this is a linear equation.
Because it's not a coefficient. Orası
Yeah, because it is in this form. We have y prime, coefficient of y prime is completely a function of x. We have y double prime. We have y prime and its coefficient is completely a function of x. We have y, its coefficient is a completely function of x, and the other side is also a complete function of x. So this is a linear one. And not to confuse it, let me clean it. Okay, because that is for the nonlinear examples. Okay. In this subclass of linear equations, we can talk about linear equations with constant coefficients. What do we mean? Instead of these functions of x, we only see numbers appearing. Okay? Like this one. 1, 1. 2, 0, 3, 1. Okay? These are all equations which come as linear equations with constant coefficients. Okay? Studying this kind of equations are going to be important for us, especially when we are trying to extend our theory to second order differential equations. Anyhow, we will come back to them. What about some other examples of linear equations? The general form of first order differential equation which is linear is like this. Let's write it as P of x y prime plus Q of x y equal to, let's call it R of x. Okay? Okay, this form of what we can do, we can always get rid of this coefficient. Okay, here I'm not talking about that. The special cases that, okay, if there is this places that p of x is equal to 0, then what should we do? Or if it is not continuous, I don't, this kind of things. Just assume that everything is going to work smoothly, okay? We can also write this equation as y prime plus p of xy equal to, let me call it q, or capital R, why not? R of x, okay? For this capital P of x being equal to q of x divided by p of x, and r of x being equal to small r of x again divided by p of x. Okay? We are much more comfortable working with this form. Because, you know, if this form is given for us, just divide everything with p of x, and then you have it in this form, okay? This is going to be much more useful for us. So this is the general form of first order linear differential equation, okay? There is also another terminology here that we need to understand. When we are calling this linear equation a homogeneous equation, okay? Or when we call it a non-homogeneous equation. This is actually an abuse of naming conventions because we are using homogeneous for different things. This is actually the third occurrences of the homogeneous, okay? But you need to be able to understand what is the context and what we are talking about. When we are saying that this linear equation is homogeneous, so a equation is homogeneous, a linear equation is homogeneous, we mean that p of x, the right hand side, is going to be equal to 0. And if this is not equal to 0, then we call this linear equation a non-homogeneous one. Okay? Good. So please don't mix it with homogeneous equations or homogeneous functions and this kind of things, okay? This is different. Yes, if this equation is equal to 0, it is called homogeneous. If not, it is not homogeneous. Okay? Good. I need to have some space, so let me just get rid of this because you know what is that. Let me open up some new space here and what about the general form of second order linear equations? When you're talking about second order equation, you are talking about what? Only this part. And the rest is just 0. So what is happening is this. We have this form, but again, like what we did here, we can divide it by the coefficient of the highest derivative of y. So we can number 1 over here as coefficient and the rest. So it is going to be looking like y double prime plus p of x y prime plus q of x y equal to, let's call it r of x. Okay? And this is going to be the general form of second order linear differential equation. Again, if the right hand side is equal to 0, we call this second order differential equation, which is homogeneous. If it is not equal to 0, then this is a linear second order ODE and non-homogeneous. Okay? So you need to just try to spot on what form of equation you are having, okay? After we have dealt with the form of equation, then it is going to be much more clear what's happening, okay? So, what I need to do this. I'm not going to talk about nonlinear equations today. I'm going to talk about linear equations. But not about the general case of linear equations. We are going to talk about this. Okay? First order differential equations. Linear ones. And we will try to see if they are homogeneous, how can we solve them? If they are non-homogeneous, how can we solve them? And so on and so on and so on. And maybe we can slowly start developing theory towards this. But before coming that, we will study equations with constant coefficients. Okay? This is the whole schema that is going to happen if you want to understand the big image. Okay? Good? Okay, let me clean here. Generally, even this pendulum equation, because we are interested in understanding why equations are nonlinear and linear, right? The case is that if they are nonlinear, we almost have no analytical tools to attack them. And they're extremely hard to solve. We need to use some numeric methods and so on and so on and so on. So it is completely a different world. So the aim is to try to understand, okay, what is the linear part? How can I understand the linear systems? Try to develop some tools which maybe we can extend it, generalize it into the case that we have in nonlinear cases. Okay? For instance, if I have this nonlinear equation of this pendulum, and if I make this small angle approximation to turn it into a linear one, now I have simplified the equation, but if I do not have any idea how to solve these linear equations, then again I'm not able to solve it.
To understand, did we ever in our previous
Okay.
any nonlinear equation?
Yes, of course.
Okay, so we are kind of like grouping them.
Yes. You see, for first order differential equations, I have given you some ladder, right? So this, do this, okay? I'm right now giving you some another perspective as well. That okay, if this is the differential equations, you can look at from non-linear part, from linear part. If it is linear, then is it with constant coefficients? What is its order, and so on and so on, okay? It's like a branching tree of classification of these different differential equations.
So we learned how to do it, now we are classifying it.
You have not learned how to do it. And you're not classifying anything. I'm just trying to give you ways to look at the problems and try to understand what kind of problem you are dealing with. Okay? If I give you, for instance, this y prime plus 2y equal to, I don't know, e to the power of x, let's say. Okay? And if I ask you to solve it. Is this a first order differential equation? Yes. But how are you going to solve it? Up to now in this ladder, we haven't come with a case with anything, right? So I'm also developing the rest of that stairs. That okay, if you do this and your equation is not an exact equation, you cannot find, I don't know, maybe integrating factors, then try to see if it is linear or not.
It's like a new step.
Yes, we are just giving some different perspectives. That is the whole case. Good? Okay. First order. Okay. Let's continue. What was the general form of a first order linear equation? Y prime plus pxy equal to q of x, right? This is the general form of a first order differential equation. Let's start when px's and qx are constants. Okay? Such that y prime plus y, and the equation is going to be homogeneous, equal to 0. Is this a first order linear differential equation or not?
Yes.
And it is homogeneous, okay? Because the right hand side is equal to 0. Now, can you please solve this equation? Well, I think you already know how to solve this kind of first order equations with constant coefficients, and then they're homogeneous. You know how to solve them. What is the case? What we need to do here? We are dealing with first order differential equations, right?
I will check first, is the differential equation yes?
Yes.
Is it separable or not?
Yes, definitely, exactly. So, is this separable or not? Yes. It is separable. Can you please separate and do the integration? We are just separating the variables and do the rest. After separating the variables, we have a valid differential form on the left, we have a valid differential form on the right.
Why is it
So,
C to the minus 6?
what?
Why is it equal to C, which is a constant?
I don't care. You already know this, so it is not that much important. Okay? But you should know and you should be able to look at the problems from a different perspective as well. Although yes, this is a separable differential equation and we know how to solve it, okay? But can you also look at it from linear perspective? Is it a linear equation or not? This is what I'm trying to achieve.
Sorry, but
What?
I have a question.
Yes, please.
Where did the x come from? Came from that there's an equation of x.
We check, no, we have a, this is our convention, right? Y is going to be a function of x. This is actually y prime of x plus y of x equal to 0. This is actually this equation. But since we are lazy, each time, instead of writing that, just write this.
Still don't understand how did the x come from. Can you write the full thing?
You see?
Understand that minus x, the x squared.
Look at this. Okay, just a second. What is this? Can you please solve this?
No, how have we gone here?
Just a second. I will come,
Alright.
just let's go. What is this going to be? ln of y equal to what?
Minus x squared over 2.
Okay, what is y then? C times e to the power of minus x to the power of 2 divided by 2, right?
Right.
This y, this is actually y of x, right?
Right.
You say where is this x is coming, right? X is actually this. When we are talking about y, we are actually talking about this. So, what we have written here means this. C times e to the power of minus x to the power of 2 divided by 2 plus c times e to the power of. Did you have a mistake? Yes, you had a mistake. Oh, you're saying where is this x? I have a mistake. This is why. Yeah. Minus p of x. I don't know why I have written minus x dx.
Where?
Okay. I completely understood you wrong. Sorry about it. Okay. Anyhow. Is this clear what's happening? Yes, please.
Is it Q or G?
Does it matter?
No, but
This is Q?
on the page you have to-
Q. But if you want to write it G or write your name parentheses X, it doesn't matter at all. Q yazıyor. Ne yazarsın lütfen? Allah sizi geliyor. Ben çok da kalabalık değil. Çok şey oluyor. Ben kalabalık. Sorry about it. Yani düşünüyorum. Bir şeyler oluyor. Okay. So what is the next level of complexity that we can add to this kind of an equation? Instead of making it homogeneous, we can make it non-homogeneous, right? We can do what, for instance?
Integration.
Let's just talk about first the constant coefficients. If I add a number here, for instance 1, then what is going to be the fate of this equation? It is not homogeneous. It is non-homogeneous first order linear equation. But again, are you able to solve this equation or not?
Separate.
Yes.
Why not separable? It is again separable, right? Just this time it is going to be dy divided by 1 minus y equal to, without any x's, and the rest, okay? Good. What is the next level that we can add to this structure? Start adding non-constant. Okay, for instance, y prime plus p of x y equal to 0. If you have this kind of an equation, how we are going to solve it? For instance, y prime plus sine of x times y equal to 0. Y prime plus x to the power of 2y equal to 0. These are all like this, right? How can we solve this differential equation? This homogeneous first order linear equation. What?
First, I will check is separable.
Yes, definitely. Again, we are dealing with the differential equation, right? What was in that ladder? To first check if it is separable or not. Is it separable? First check it. It seems it is separable. Can you please separate the variables? What we are doing is this. This is dy over dx. Dy over dx equal to minus px y. Right? Then I can write this as dy over y equal to minus px dx. From here, what do I get? I do get ln of absolute value of y equal to integral of this minus sign, let's put it out, p of x dx plus a c. Okay? If you want, you can also write it to the power of something something, but for me, even writing this is enough. Okay? But let's do the rest. Can I write this equation? Can I write this equation in the form of absolute value of y equal to c times e to the power of integral of minus px dx? This c and this c are necessarily not the same thing. That's why I'm adding a c0 for instance here. How we can do it? This is e to the power of this integral times e to the power of c0, right? E to the power of c0 is just a constant. We call it c. Okay? Question. We are still having this absolute value of y here, right? Sometimes we have normally tried not to talk about it and just sweep it under the rug, okay, and just pass about it. But we have absolute value here, right? How can we get rid of this?
You can see it as minus and plus,
Yes.
and then try to solve it. Like, for example, when you see it as minus, it's calculable, as I remember.
When you're saying that, okay, calculate it or try to solve it, what do you mean by that? It's not exactly very clear. So what I'm going to solve? You need to have some different kind of argumentations. Okay? Look at this. When this is happening, let me write this in this form. Y of x times e to the power of integral of px dx equal to c. Okay? I'm just taking this, bringing it to the left-hand side, okay? And if I want to get rid of this absolute value, what is this going to be happening? Y of x times e to the power of integral of px dx. This is going to be plus minus c, right? What I'm trying to say for you is this. We can get rid of this plus or minus. How? You're actually going to use a theorem from calculus that you may remember. And what was that theorem? It is called intermediate value theorem. Remember that if we have a continuous function, okay, let's have something like this. If this function takes this value, for instance, or any other value, let's call it this value from here. If this function is continuous, then it must take all of the values here in between of these two values, okay? Look at this. This is a continuous function. By our assumption, we have talked about what? Continuous functions, right? We have said, okay, we do not have anything to do with continuous cases, so let's assume that everything is working. This is a continuous function, this is a continuous function, okay? So this whole thing is actually a continuous function. If a continuous function takes some value here, which is called c, and some value here, which is minus c, then this continuous function must take all of the values that come in between of these two, okay? But look at this. It is just this one or this one. And it cannot then take both of these two values, right? If it takes this one and this one, then it must take all of the values in between as well. But since because of this identity, we cannot say that okay, it also takes all the values in between. It only takes the values such that their absolute value is equal to c. Which means that this function itself must be completely equal to c or minus c. Okay? And this is actually either plus c or minus c. Completely this one or completely this one. You cannot jump between these two. Okay? And this was just a constant, right? So it is either c or minus c. So I can call it another constant. Let's call it c prime, c0, c1 or whatsoever. Okay? What is the meaning of this? The meaning of this is that using intermediate value theorem, we can get rid of this absolute value. So from now on, when we are taking integrals and we are having this kind of thing, you can secretly use this intermediate value problem and say that, okay, what? Just get rid of it. Like what we are going to do here. You're just going to write class C. Okay?
Question.
Yes, please.
So this equation graph must not look as the one at the side. It must be linear.
The equation of this function, this whole thing, must be something like this, or it's minus.
Yeah, I can understand because I thought the graph is connected to the equation. I can understand.
Yes, but multiplication of two functions being a constant, it doesn't mean that those functions are constant. It can be versus x and 1 divided by x. So if you draw x, draw 1 over x, you will see completely different things. So this is not a constant, this is not a constant. When they are multiplied, they are a constant.
Yeah.
Which gives us y of x is equal to c times e to the power of this. Okay? Good. So this is the general way. This is the general way that we can solve first order linear equation, homogeneous with non-constant coefficients. Okay? Good.
Can I ask?
Yes, please.
C constant.
What?
C. C.
CE. What?
The A constant. The equals.
Okay.
J minus. But earlier getting rid of L and L, we just used to get rid of it.
We have done this. We have done this, right? This is e to the power of
Yes.
minus px dx plus c. C0, let's call it. Can I write this as e to the power of c0?
Yes.
The bases are the same, so exponents are added. Now, is this a constant or not? It's a constant. Instead of writing e to the power of C0 or e to the power of something, can I just refer to it as just a C? Yes, I can. This is what we are doing. Okay. What is the next step?
Make
If you want-
0 equals to 1.
Yes, definitely. Make this, and let's generalize it. Instead of just writing just something, let's go with some function of x, like q of x. Okay? So this is a first order linear differential equation which is non-homogeneous. Now question, can we solve this differential equation? How can we solve it? We had some ideas, now please send them. How and why? Why you are coming with that idea? We are going to multiply this equation with something. That was actually the Euler's genius, I think, that Euler has figured out it for the first time. Also, the integrating factors is, I think, the works of Euler. But anyhow, if we can also systematically go on that ladder that we had, okay? Can we also come up with that idea of what we need to multiply with this? Or even if I do not know how to multiply this with something, or if I have absolutely no idea that I'm going to multiply this with something, how can I understand it? How can I find it? Tamam. Let's go. Is this a differential equation or not? It is. What is its order? It is first order. Is it separable or not? It is not separable. Is this in the form of y prime equal to f of x y such that f is a homogeneous function of degree 0? Again, no. What was the second case? M dx plus n dy equal to 0 or something, such that m and n were homogeneous functions of the same degree. Is this in this form or not?
Yeah, it is.
Yes, we can turn it into this, right? Let's turn it and see. Let me just clean it. How can we turn this differential equation written in the differential form? This is dy by dx, right? You have a question?
Yes.
Please.
How do you define m and n? Can you say it again?
It is just a function of x and y. It is just a function of x and y. This is the question. I'm not saying that this is like this. I'm going to define m. I'm going to define it. We were just checking that ladder. Is it separable or not? Is this or not? Okay. We also have this case, right? Then we have this case such that m and n are homogeneous functions of the same degree.
Same
Homogeneous functions of same degree.
m and
Homogeneous functions of same degree, yes. For instance, x, y, x to the power of 2. This is homogeneous of degree 2. This is homogeneous of degree 2.
okay, but how do you know this is the case of this function?
We do not know. We are trying to see if what we had for our ladder. We were checking. If this is, then solve it like this. Then not go to this next step. Go to the next step. This is what we are trying to do. You are losing me a lot today, I think. The exams are really... Okay, so what we need to do, we need to first turn this problem, welcome, into this form and try to see if it satisfies it or not. We have this dy divided by dx. What can we say? We can say dy and multiply everything with dx. I'm also taking this to the left hand side. Plus d of xy minus qx dx equal to 0. Now look at this. Now do I have some m and n? M dx plus n dy. This is my m. What is my n? This is the one, right? Okay. Question. Is this homogeneous of same degree as homogeneous as this? No, they are not. In some possible cases maybe, but generally no, it's not like that. Then what was the next step in our ladder? Is it exact or not? Is this an exact equation or not? What was the definition for exactness? Yes, go on. Let me write it. Round of n, Omar. Round of y equal to round of n or round of x. This. Okay? Let's check it. Is it satisfied or not? What is the derivative of m with respect to y? What is the derivative of this expression with respect to y? P of x, yes. So this is equal to p of x. What is right hand side? Derivative of this with respect to x is 0. They are not always equal. Except the case that p of x is equal to 0, they are not going to be equal, right? So this means that this equation is not an exact equation. Okay, what was the next step? Do we have any integrating factor such that we can turn this equation into an exact equation? We have this equation. We want to try to understand how can we solve it. We had this algorithmic approach, right? Some kind of a guideline that check if it is separable or not, check if it is this, check if it is that or not. Okay? And we are just climbing that ladder step by step. Up to the exactness, we do not have the case. This is not always an exact equation. So what was the next question? It was this. Do we have any integrating factor such that if we multiply this equation with that integrating factor, then we are going to have an exact equation or not, okay? Can you find an integrating factor for this equation? What was the cases that we were checking? Yes. If this is a function of x, only x, then e to the power of integral of this is going to be what? Our integrating factor. If this divided by minus m is only a function of y, then e to the power of integral of this is going to be an integrating factor, okay? Let's check it step by step. Unfortunately, it's just going to click here. Please.
Alright, so last lecture we got the equation that mu xy is equals to x power of alpha y power
Yes.
beta, and I think you said that we can use it directly.
Yes, can you use it directly here?
I tried, but
It's not always going to, because you know, here you do not know p of x, here you do not know q of x, such that you can multiply and try to see what's happening. It's not that simple, so you need to make this general cases. No? Are we here solving any particular kind of example from a differential equation?
I can't know who's alpha, who's beta, because I don't know the x's inside this equation.
Yes.
It's not true.
We are not solving any problem right now. We are trying to solve the general case of it. And in the general case of it, don't look at the specifics. Because I do not have p of x, I do not have q of x. If I have them, for instance, maybe if they are polynomials, then yes, you can use that trick in order to find an integrating factor.
So in the exam, I need to go step by step. If it's
Yes, you are always going to. Yes, definitely.
I can't just turn this directly if I found that.
If you can do it, do it. There is no problem with that. But does it work here? In this case, no. So it is not working, you see. And when it is not working, why to do it? You just need to say that, okay, it's not working, let it go and look for somebody else, okay?
Alright, thank you.
Anyhow, yeah, no problem. What is this? We have calculated this as p of x minus, this was 0, divided by n, which is 1. This is going to be p of x. Is this only a function of x or not? Yes, fortunately it is only a function of x. What is the meaning of this? This means that our mu is equal to the power of px dx. What is the meaning of that? It means that if we multiply our equation with this expression, then we are going to have an exact equation. Okay? Working with this case, I'm leaving it for you. I'm coming back to this part. What I have to do, now we said that this equation we have, if we multiply this equation with that expression, then we are going to get an exact equation, right? But since I am working with the linear forms, I'm giving these details for you to fill in, okay? And I'm just going to do that. If I try to multiply this with this expression, am I going to get something useful or not? So let's go back to it and try to see what's happening. So you see, you said that you're going to multiply it with something, right? You see from where it is coming? Step by step, go and... Anyhow, if you multiply this equation with that, then what's going to happen? This is going to be y prime e to the power of integral of px dx plus px e to the power of integral of px dx y equal to q of x e to the power of integral of px dx. Okay? Let me give you first some examples. Maybe it is going to be much more clear. If we have this kind of an equation, it is a first order linear equation and which is homogeneous, right? Non-homogeneous. So it is this case. We are going to multiply this equation with what? With mu equal to e to the power of integral of what? X dx, which is going to be e to the power of x to the power of 2 divided by 2. Okay? Let's multiply it. So we're going to have y prime e to the power of x to the power of 2 divided by 2 plus x e to the power of x to the power of 2 divided by 2 y equal to x to the power of 2 to the power of x. Okay? A lot of x's. But look at the left hand side. Or left hand side of here. What do you see? Do you see something like that? Y times e to the power of x to the power of 2 divided by 2's derivative. Is it like that? Why not? Because if you want to take this derivative, what do we do? This is, yes, multiplication rule. Derivative of the first one, y prime plus, derivative of the first one times the next one, plus derivative of the second one, and what is the derivative of this? E to the power of x to the power of 2 divided by 2, multiplied by the derivative of this, we use the chain rule. So it is going to be 2x divided by 2, which is x, multiplied by the first one. Okay? Can you see it here as well? You see, what can I write here then? This is going to be derivative of what? Y times, yes, integral of e to the power of px. Yes, definitely. But just a second. So, is this really clear? Why this is equal to the derivative of this? Because if you want to calculate it, derivative of the multiplication is equal to derivative of the first one times the second one, derivative of the first one times the second one, plus derivative of the second one, which is derivative of e to the power of integral of px, which is itself multiplied by derivative of this expression, right? And what's the derivative of integral of p of x? It is p of x. So px multiplied by the first one. Okay, equals this. Good? We are just here solving the general case. There is no need for you to memorize none of these, not at all. You just need to understand we need to multiply it with something such that it is in the shape of multiplication's derivative. Oh. So if this derivative is equal to this, then what is this equal to? This is going to be equal to integral of this, right? Indefinite integral of this such that we have y of x to the power of integral of px dx is going to be equal to integral of qx e to the power of integral of px dx, another dx here. We can also turn this into pt dt, not to mix it, but you know, if I change this to some other variable, then this is going to get complicated. Although we are taking an integral inside an integral, it is better to keep this just as x's, okay? Plus c. From here, what is my y of x? It is going to be equal to e to the power of integral of minus px dx multiplied by this whole thing. Q of x, px dx, plus c. I also have a dx here. Good? This is the general form of solution. General form of the solution. Solutions of. How many solutions of y prime plus pxy equal to q of x. Okay? Do we need to memorize this? Not at all. We just need to understand what is happening. And what is happening is this. Left hand side, we multiply it with something such that we can have this. Okay, let's see some examples. Can you please solve this differential equation? Again, is it separable, not separable, exact, not exact, equation with homogeneous functions or not? You will come to the point that you will see that this is a linear equation of first order, which is non-homogeneous, and opposite the way, so it is in this form, right? So how can we solve it? With what I should multiply this equation such that this becomes derivative of multiplication of two functions? We need this, right? If we calculate this, what is this going to happen? Here, what is our p of x? 1 divided by x. What is our q of x? 3x, okay? With what we are going to multiply? We are going to multiply the equation with e to the power of integral of px dx, which is 1 over x dx. And what is that?
X.
Yes, this is e to the power of ln of x, which is x. Okay? So what is the meaning of this? It says that just by multiplying this equation with an x, you are going to get the left-hand side equal to the derivative of x times y. If you multiply this equation with x's, then what do we have? xy prime plus y equal to 3x to the power of 3. What is this left-hand side equal to? Is this derivative of x times y? Derivative of the first one multiplied by the second, which means y of x, plus derivative of the second one, y prime, multiplied by the first one, xy prime. This is equal equal to 3x to the power of 2. Then what do we have? If this derivative is equal to this, then this x, y of x, here I'm trying to not to be lazy and write this x. This is going to be equal to integral of 3x to dx. And what is this equal to?
X cubed.
Yes. So, what is my y of x then?
It's
Y of x is 0x.
X to the power of 2 plus 0x. You see, now I have the y, the function y. If from this function, can you verify that this is actually a solution for this equation? How do we do it? Take the derivative of this function and replace everything. Then you will see that left hand side is going to be equal to right hand side. Good? Let's solve this initial value problem. Okay? What do we mean by this? You're just going to solve this first order, linear, non-homogeneous differential equation. Then we need to also find the value of c. Okay? By replacing x is equal to 0 and y equal to 0. Okay? And try to see for which value of the c this is satisfied. Can you please solve it? Let's solve it. Let's solve it. What we are trying to do is this. Can I write the left-hand side as the derivative of y times some other function? Because if I can do it, then the rest is easier, as you have seen. But the question is this. Is the left-hand side of this equal to the derivative of y times something? It is still not. Why not check it and think about it? But is there anything that, if I can multiply this equation with that, the left-hand side is going to turn into derivative of y times some function? We are saying actually yes. There is this kind of a... Let's multiply this equation with that. So what do we have? Y prime is the power of minus x to the power of 2 divided by 2 minus x to the power of minus x to the power of 2 divided by 2 y. Okay? What do you see in the left hand side? Now, is this left hand side derivative of y times a function? Is it equal to derivative of y times something? If we take derivative of y times something, what do we have? Derivative of y times that something plus. So, to be writing here, to be able to find what we need to write here, we just look at the coefficient of y prime, right? What is multiplied with the y prime? And what should multiply with the power of minus x to the power of 2. Okay? Does it make sense really? Yeah. Okay, now look at this. What is this derivative? Let's double check it. If you calculate this derivative of multiplication of two functions, what is it going to be? Derivative of the first one multiplied by the second one. Derivative of the first one multiplied by the second one. Plus, derivative of the second one, what is the derivative of e to the power of minus x to the power of 2?
Minus x.
If this is u, it is going to be e to the power of u times u prime, right? So it is going to be e to the power of minus x to the power of 2 divided by 2. Multiplied by what? Derivative of this. And what is that? This is x, right? X times e to the power of minus x to the power of 2 divided by 2. Now look at this. With a minus, of course. This is is not x, this is minus x. Okay?
It's
So minus
x over 2 minus x over 2 x.
Now look at this. What is the derivative of this? Derivative of the first one times the second one. Derivative of the first one times the second one. Plus derivative of the second one times the first one. Equal to this. X e to the power of minus x to the power of this one. Good? Okay. Now, how should we continue? What is the next step? So, if this derivative is equal to this equation, so y e to the power of minus x to the power of 2 divided by 2 is going to be equal to the integral of x e to the power of minus x to the power of 2 divided by 2 dx. Can you please calculate this integral?
Oh yes. Where is it?
And this, just make this equal to u.
It's minus d x squared over d plus c.
What is our du then?
Yeah, this is right. D is equals to minus x dx.
Minus x dx. This x with this dx, I'm just going to replace it with minus du. So what do we have?
Minus du is equals to x dx.
Minus integral of e to the power of u du. But you can calculate that, right? Easily. E to the power of u du is integral. It is e to the power of u, and what was our u? Minus x to the power of 2 divided by 2. Okay? Plus our c. Okay? Now what is going to happen? Now our y of x is going to equal to, you see we have y times e to the power of minus x to the power of 2 divided by 2 equal to this. What is y then? Y is equal to, just multiply it, e to the power of x to the power of 2 divided by 2. So we can get rid of this. Or divide each part of this with this. So y is going to be this, multiplied with this one. It's going to be minus 1, I think. Because this x1 and this x1 are just going to cancel each other. If you take this to the other side. This is going to be positive, that negative, they will sum up to 0, so it's going to be 1. Plus c times e to the power of x to the power of 2 divided by 2. Okay? This is our function y. But we are given an initial value problem. What is it? It is asking us to, yes, it is telling us that calculate the value for c such that whenever you place x equal to 0, you are going to get y0 equal to 0 or y equal to 0. Okay? So if we write x is equal to 0, what do we have here? Left hand side is going to be y of 0, which is given as 0. 0 equal to minus 1 plus c, right? Because e to the power of 0 is also 1. So 0 is equal to minus 1 plus c. From there, what is our c?
1.
C is equal to 1, right? Now that I know the value of c, I just replace it.
Yeah, it's going to be
Yes. And the solution for this initial value problem is going to be this.
Yes.
If it changes, for instance, to, let's say, 1, then what is going to happen?
0.
1 is equal to,
There. 2 to become 2.
no, you are forgetting the 6 as well.
Oh yeah.
Don't be. Of course, this is going to be some 0 again, but don't forget, don't just behave it that, okay, this does not exist. Okay? Maybe in some other cases, this is x times c, and when x is equal to 0, that c is also, being eliminated, but in some other cases, it is not getting eliminated.
How do we calculate it without, like, for example, a calculator in the exam?
The value of c,
No, the value of, for example, if like it's 1 or 2 or 5 maybe.
you will not get any questions like that, that you cannot do it without any calculator, so don't worry about it.
Okay.
No problems for the exam. What is the value of c for this initial value problem? Yes, again we put 0 in place of x's. 1 is equal to minus 1 plus c. 1 is equal to minus 1 plus c. So c is not 1 actually, but 2. So for this initial value problem, this is going to be 2. Or the rest, and so on and so on. Okay? Okay, let's continue. What has happened so far? We have been talking about first order differential equations, right? What we have been trying to do is that we were trying to make some step-by-step approach to solving first order differential equations, okay? If you look at that ladder, okay, sometimes there are some cases that do not fit into any one of them, okay? And we need to have some branches. One of these branchings is happening when we are having this kind of an equation. This is called Bernoulli's equation, actually.
It's not linear, right?
No, it is not linear. Why it is not linear?
Because the y has an power.
Yes, power of n. Now, question is this. If we have this kind of an equation, can we turn this into a problem that we know how to solve?
No,
We have to
because we
check the
didn't
table
solve.
first.
No, because we didn't solve nonlinear equations.
But the question is, I'm not talking about solving nonlinear equations. Is there any trick that we can use in order to turn this problem into a linear problem?
It's not separable.
It is not separable. It is actually none of those cases there.
Take the derivative of n.
Okay? What should we do? Let's go step by step first of all. When our n is equal to 0, what is happening to this equation?
It will turn into a linear.
It will turn into a non-homogeneous linear equation, right? Because this is going to be pxy equal to q of x. Non-homogeneous. Non-homogeneous linear first order differential equation. We know how to solve this. What about n equal to 1? Then what?
It might be a homogeneous
Why?
because all the powers will be same.
Yes, and we can take it. So it's going to be y prime plus px minus qx y equal to 0. Okay? Again, we know how to solve this. But what about when our n is greater than or equal to 2? What happens then? The thing is that we can use this change of variable z equal to y to the power of 1 minus n. Okay? Why this works, I also don't know. But what should we do? We should check it out, right? How can we check it out? We're using this kind of change of variable. Let's take derivatives of both hand sides, because we need to something to be replaced in y prime. And the only way that I can extract this y prime is that by taking the derivative. So z prime is going to be equal to 1 minus n, what? Y to the power of?
1 minus 1 minus n?
Yes, which is?
2.
Minus n times y prime. Okay? Look at this. What is this saying? Look at this and look at this equation. How can we manipulate this equation in order to come to this? Or use this in order to reduce this into something that we are familiar with?
I guess we put the y power into one side and then the rest in the other.
Yes? Look at this, by the way. If we multiply both hand sides of this equation with y to the power of minus n, what is going to happen?
The y and the n basically the power will be 1.
Yes, y to the power of minus n y prime is here, which which I'm going to replace it with z prime divided by this. Okay? And here, this is also getting cancelled. What do I have here? I have y to the power of 1 and minus n from here. That is going to be y to the power plus these two, which is going to be equal to z, right? It seems that this kind of change of variable is turning this problem to. Let's control it. So we'll see that it is actually doing it like that. This equation, take it and multiply it with what? This expression. Okay? So what are we going to get? 1 minus n times y to the power of minus n, y prime, plus 1 minus n px y to the power of 1 minus n, right? We're just multiplying both hand sides with this, equal to 1 minus n qx. Is it clear? Multiply by 1 minus n times y to the power of minus n. Okay? Just take this, multiply it with this expression. Now, what do we have here? Instead of this, what can I write? Z prime. What about the rest? 1 minus n px z or z. I'm also using the interchangeable symbol. And it stays as it is. Now, question. Is this a first order, linear, non-homogeneous differential equation of the variable?
Yes.
Do we know how to solve this?
Yes.
Yes, we definitely know how to solve it. Like what we have done to the rest of it. Okay? So, example. X to the power of 2 y prime plus. Let me use one of my examples. What do I have? Yes. Please solve this equation.
Sir, do we have to do the exact same thing we did with the function?
You just need to use this change of variable.
1 minus n.
Yes.
1 minus.
Y to the power of 1 minus n. But what is our n here? First of all, we need to understand that.
That's 3.
But look at this. What was the general form of the Bernoulli equation? We normally try to say, okay, let's make this equal to 1. Okay? So divide everything with x to the power of 2. Turn it into this standard form. Then decide on what is n, what is those things, and what we need to do.
İlk başta bir iskandal tutulmaz.
Yes, just get rid of it. So it is going to be y prime plus 1 over x to the power of 2 y equal to x to the power of 2 y to the power of 3. Is it really visible that this is a Bernoulli equation or not?
So I forgot what Bernoulli equation is.
What?
So this is a Bernoulli equation.
This kind of equations are called Bernoulli equations. For n equal to 0 and n equal to 1,
Basically,
it is basically useless, yes. And for n greater than equal to 2, degenerately, this is called the Bernoulli equation. Okay? So, what kind of change of variable we need to do here? What is our n?
3.
N is equal to 3, yes. So, what do I need to do? I need to take z equal to
Or y power minus 3 or 2 minus 3, I think.
1 minus 3. And what is 1 minus 3? Minus 2. Minus 2.
1 minus, actually minus 1.
This is 3, right? So
Yes.
it's going to be 1 minus 3, which is going to be y to the power of minus 3. Okay? Good? What about the rest? You have the recipe here. You have the recipe here. Can you please apply this recipe to this equation? What we are trying to do when we are working with the general cases, this is exactly like giving your recipe. Can you follow this recipe and try to cook up the solutions of this equation? Something wrong. I'm just going to multiply everything with minus 2. I forgot this. Lines cancelled. I'm missing something, right? This is going to be minus 2, minus 3. Yes. Yeah, definitely right. Where is it? So we are just going to multiply this equation with this. So it is going to be minus 2 y to the power of minus 3 y prime minus 2 divided by x2 y to the power of minus 2 equal to minus 2 times x2. That's it. So what next? So what is happening? This is actually z prime. Minus 2 divided by x to the power of 2, y to the power of minus 2 was z, equal to minus 2 times x to the power of 2. Now what do we have? We have a first order non-homogeneous linear differential equation. How do we solve this? Can you please solve it? Yeah. We are going to multiply this equation with what?
With every
Minus 2 times y to the power of minus 2.
with every single variable.
Every single possible variable?
Basically, like, for example,
Then you multiply both sides. Both sides of the equation, yeah?
okay, so we're supposed to do that with z, right? With z differentiation, z, right?
We are trying to turn this Bernoulli problem into this first order linear equation. How can we do it? First of all, let's turn it into the standard form. What is the standard form? The coefficient of y prime must be equal to 1, right? So divide everything, x to the power of 2. Is it clear up to now? Okay. Now, I need to use this change of variable. If we take z equal to y to the power of 1 minus n, which is n is equal to what? 3. It's going to be y to the power of minus 2. Take derivatives of both hand sides. Z prime is equal to minus 2 y to the power of minus 3. Multiplied by y prime. Good? Okay. What I need to, in order to use this, I need to manipulate this equation, right? How can I manipulate that? Multiply everything with the coefficient of this y prime here. So this one, minus 2 times y to the power of minus 3. If you multiply that, this is going to be minus 2 times y to the power of minus 3 times itself, minus 2 times minus 2 divided by x to the power of 2, y multiplied by y to the power of minus 3. So y to the power of minus 2 equal to this hand here also multiplying this. So it's going minus 2 x to the power of 2, y to the power of minus 3, y to the power of 3. They're cancelling each other. So it's going to be minus 2x to the power of 2.
Yeah.
Good? Yes. By doing that, we are turning this Bernoulli equation into this linear non-homogeneous equation. Now, can you please solve this equation? This is the problem. We're multiplying this equation with what? E to the power of integral of this in order to get what? This part being equal to derivative of something. And the rest. Shall we solve it or you're solving it? Okay, you're solving it. Yes, please try. Let's try to see. Okay. Let me just write it here. Minus 2x2 z equal to minus 2 times x to the power of 2. Right? Okay. I need to multiply this equation with something which turns this left hand side as the derivative of z times some function. And what is that function? Our mu is going to be e to the power of integral of what? Minus 2 divided by x to the power of 2 dx. And what is this? This is e to the power of integral of, let me take minus 2 out. This is x to the power of minus 2 dx, right? How do we normally solve this kind of integrals? Add 1 and divide it.
Yes.
If you add 1 and divide it, it is going to be, yes, minus 1 over x, with this multiplied is going to e to the power of 2 divided by x. Is it clear? Okay. Now that we know this, let's multiply it. So it is going to be z prime e to the power of 2x. Let me write it. Okay. What was our story? What was our big picture? When we were dealing with first order differential equations, the first question was that, is it separable or not? The next question was that, do we have any linear expression like this in our equation? Then this change of variable is going to solve our problem. We have y prime equal to f of ax plus by plus c. Okay? Just use this change of variable. What was the next step?
It's homogeneous.
Equation with homogeneous equations. With homogeneous functions, sorry. What do I mean by this? We had two cases, right?
Yeah.
One of them is y prime equal to f of xy, such that f is homogeneous of degree 0, or we have
Degree.
m dx plus n dy equal to 0 with
F is homogeneous between 2 n.
m and n homogeneous of same degree. Homogeneous of degree n. This n can be 1, 2, It doesn't matter. As long as both of them have the same degree of homogeneity, then it's fine. What was our procedure for this kind of equations? Yes. This change of variable is going to be useful. This is going to be solve our problem. Here, this has. Okay? What was our next step? Exact equations. And what was the condition for exactness? If you have some equation which is in this form, then we need to check that if coefficient of dx with respect to y is equal to coefficient of dy with respect to x. Okay? If this is satisfied, then the equation is exact. And what we need to do is that we need to recover f from its partial derivatives. So what we do is that we are trying to integrate, differentiate, integrate. Why? Because this is the big picture, right? If we have the level curve of a function like this, our exact equation was coming like that. Round of f over round of x dx plus round of f over round of y dy equal to 0. And this was telling us that the tangent vectors and the gradients are perpendicular to each other when we are working on the level curve of this function. Okay? We have talked about this. How was our exploration? When this condition is satisfied, if this is m, this is n, when this equation is exact, we know that this kind of function exists on top of the clouds. So what was our point? We were looking at this perspective, okay? From looking here, we only were discovering one part of f, right? How did we do it? We integrated, right? We take this as m, take its integral, and then we are at the level of f plus some remaining things which are going to be functions of y, right? I need to come back to look again. So we take the derivative of what we have with respect to y, so we can use this information as well, if you remember it. Okay? We just took the integrals, then we took derivative with respect to the other variable. Okay? Again, I have this. I have been able to see half of this. So for the rest half, I again need to look from this perspective and try to see what I have for the rest of it. And what was happening? We were just again integrating. Okay? So in 3 steps of integrate, take derivative, integrate, we were able to solve an exact equation. Okay? Anyhow, what was this step after being exact, controlling if some equation is exact or not? Integrating factors. You know the formulas. What was the next one? I should have written it a little bit compacted, but anyhow. Let me come 1, 2, 3, 4, 5.
And then linear equations.
Yes.
So this is conditions.
Linear equation. Okay? You have some questions? Okay. Check this. First of all, check this. If it is works, then solved. If not, check this. Doesn't work, check this. Doesn't work, check this. Doesn't work, check this. Check this. We have a sub-branch here. What was our sub-branch here? Bernoulli equation. Okay. We can also have some other branches as well, but it is not going to be the linear. For instance, the Riccati's equation. It is y prime equal to p of x plus qxy plus some r of x y to the power of 2. It is going to get out of the linear part of our equation, so I'm keeping it for a project for you, okay? If you would like to do some project for the student seminars, you can definitely work on, for instance, Riccati's equation. It has some applications in control theory, which I'm not aware of it. It will be very nice to also learn about that kind of things. So for project problems, you can also have Riccati's equation. Anyhow, what is the next step that we are going to check? If we select all of these and none of them are working. Yes, we are going to talk about it next lecture. Then we have numerical solutions. Yes.
This kind of example.
What?
This kind of example.
No. We are not going to have it. Even for, when we are going to talk about the Euler's method or Runge-Kota, maybe I'm going to leave it as, again, project problems for you, especially Runge-Kota's problem, because we need to talk about Euler's method. But even when we are talking about Euler's method, we are not going to do anything. We are just going to go over some of the GPTs, maybe ChatGPT or some other things. Try to understand how can we make GPT to write a code for us, such that it can solve numerically a differential equation. Okay? So there is no need to worry about this at all. But go step by step. When we are done with our analytical tools that we can no more try to understand and solve it, do what? Then say that, okay, I do not have the necessary tools. If you give me this initial value problem, okay, such that the value of this equation, in the value of y in this x is equal to this. If you give it as an initial value problem for me, then I can use, for instance, Euler's method in order to solve it. We are going to talk about this. But keep in mind, first we do this. If we do not do it, then numerical solutions. Okay? I need to add a few branches here, by the way. Especially here in this part. Okay? Let me just clean this and take it here. If I want to open up a branch like this, y prime equal to f of ax plus by cx plus ey. I'm not writing d because dy, maybe it is going to be confused with the differential of y. That is why I'm using this e. And e is not necessarily Euler's number, 2 to the 0.71, the rest. It can be that number, but here it is not necessarily that.
Can we just use another letter then?
Yes.
Thank you.
A, B, C, D, E, F. F is for function, G is for function, K.
Thank you.
And if you say, for instance, K, L, M,
No,
and this kind of thing for natural numbers, then it is not a natural. General thing. Anyhow, how do we solve this problem? If for instance, you are given this equation, x plus y, x minus y. How can we solve this? What is your ideas? First try to see if it is separable or not. I think it's not. Maybe it is, but it is not. It seems it is not. Yes. So, what next?
It is homogeneous.
Is this the second step here?
No, it's
No. Is this in this case an equation with homogeneous functions?
homogeneous.
How it is? How it is related to this case? Is this case, this general case, really one of these, this one or this one. It seems more like this one, but is it like this one?
No.
Actually it is. Because let's assume our capital F of xy is equal to this. ax plus by, cx plus ky. Okay? Now, question. Is this function, but you see what we have here, we have y prime equal to f of xy, right? Now, question, if we want to solve this equation under this change of variable, we need to be sure that first, this function here is a homogeneous function of degree 0. Now, question, is this function a homogeneous function of degree 0?
Yeah, because it's 1 over 1, so it will be 0, right?
How can we know that?
Multiply all by lambda and then take the lambda aside.
Not multiply, replace it. If instead of x, you write lambda x. If instead of y, you write lambda y, you will see that yes, all of the lambdas are cancelling and there are too much noise. Can you please speak one by one? I'm not hearing none of you and probably you are not hearing me then. So, what is your point? What was your point?
You were talking about lambda.
Yes, definitely. So let's look here. If you replace x with lambda x, y with lambda y, and just take the parentheses and the factor out, then lambda is going to cancel, so this function is itself going to pop up. So in these cases, we are able to use this information to categorize this problem here in this case, right? So, in order to be able to solve this problem, what do we need to do? We just need to do this change of variable, right? Now, question. Can you please use this change of variable in order to solve this problem, for instance? What do we need to do? Z is equal to y divided by x. Then what is my y? Y is equal to xz. Take derivatives of both hand sides. This is going to be y prime, derivative of x, z plus. Okay? But what is y prime? What is y prime? X plus y, x minus y, right? We have proved that this change of variable turned this problem into a separable problem. Okay? When we have separable differential equation, we actually have two variables, right? Because we are going to write an equality. Everything that's related to one variable times d of that variable on one hand. Everything related to the other variable times d of that variable on the other hand, right? So we have two sides of an equation, an equality. So we need to also have two variables, not three. So how can I get rid of one of these variables? Of course, we are replacing everything. Yes, exactly. Instead of y, just write x times z. And if you write x times z instead of y, what are we going to get?
Now it's separate.
Now, look at this. We can also take a factor out of x's, okay, and cancel them. So this is going to be 1 plus c, 1 minus c, okay? Now, one more step. What's going to happen? I need to separate the variables, right? So this one I need to bring minus c, and this minus c, since I need some common denominator, I just write it as equal to x, z prime. Then what I'm going to get? 1 minus c plus c minus c plus c is equal to x z prime. So is this now a separable differential equation or not? It is. How can we separate it?
We say 1 plus b.
Let me write it. Is equal to dx divided by x. Okay?
Ln x.
No, not ln x.
Ln x.
Yeah. Right hand side is ln of x. What about left hand side? How do we calculate this integral? We need to break this into two different parts, right? 1 divided by 1 plus z squared, and what was that integral? I do not have that much space, that's why I'm trying to integral us. This is equal to ln of x plus c. Okay? What is this integral? Integral of 1 divided by 1 plus z, arctangent of z, minus, yes, exactly, or you can add a 1 divided by 2. I'm seeing the denominator is derivative in denominator, so it is going to be ln of denominator, and it is going to be some expression. Then, instead of z, wherever you see z, you're just going to come and replace it with y divided by x, and we are done. Okay? Oh my. What if I have this kind of an equation? Ax plus by plus c qx plus px qx. I am just adding some branches to this ladder. This was one addition, this is another extra addition. For instance, if we have, now this is a problem. If you have this kind of a x plus y minus 4, x minus y minus plus 6. Or let me, I had very similar question to this. Let me try to find that. X plus y plus 4. X minus y minus 6. Which one? Here, ax plus by plus c, px plus qy plus r. Yes, r or any constant. Here, for instance, a is 1, b is 1, c is plus 4, p is 1, q is minus 1, r is minus 6. Okay? How can we solve this problem? Yes, please.
The top of the division are like the I stays up.
This one?
Yes.
Okay.
So maybe we can separate it with farklı olarak farklı bir bölü olarak yazsak.
I understand your point, but the case is this. You're definitely right about this, but in this case, you see, you have exactly the same thing. But we are going to have different coefficients. Then this is not an expression of ax plus by plus c. This is something different. I don't think so. Try it. Try it. You see, there is this case. We have two lines actually here in this space, okay? If these two lines are parallel to each other, then we will see. We are just going to talk about it. Then one of them is going to be expressible in this form. So you are just going to take ax plus by equal to some z, and then in the denominator, yes, you are going to see that expression as well. So it is going to work. You are be right about it. But you need to, again, based on the problem, try to see what's happening.
I think what we have to do is that we have to do equation with homogeneous functions, but homogeneous degree is zero, I checked it.
Okay.
And then afterwards we use the second part, okay, z is equal to x plus b.
Okay.
And after trying to separate it and make it
Okay. This is not a separable equation. This is not also in this form.
okay.
Okay.
But we can do the same homogeneous one.
Yes, but the problem is this a homogeneous function?
Kinda, yeah.
It is not. Either it is or either it is not. There is a kind of,
The constants, like, messed up.
Yes. Here, what is messing up the problem? These two constants, right? How can we get rid of them? Because if we can get rid of them, then we can turn the problem into what we know how to solve it.
We can multiply both sides with 4 over minus 6.
You're also doing it for this hand, right? So you're changing the problem then. How can we do this? First of all, let's assume that. This is, for instance, our line ax plus by plus c equal to 0. Let's assume that this is px plus qy plus r equal to 0. Okay?
Also, you find simultaneously.
Yes.
Intersection.
The first assumption that I'm going to make here is that assume that these two lines are not parallel. How can we know these two lines are not parallel?
Equal to each other.
Their coefficient is not same.
The coefficients are not.
Same. Yani katlı değil.
Yes. Coefficients are not multiples of each other. Or you can also say that just calculate this determinant a times q minus b times z. What you're saying is this. These two lines are parallel to each other if and only if a divided by p is equal to b divided by q. Okay? What you're saying is this, right? But this is equivalent to saying that aq minus bp is equal to 0. If they are parallel, this is true, which is this actually. I'm just multiplying and taking everything. But we're assuming that they are not parallel to each other. So this is not equal to 0. This is not an inequality. And we have an intersection point. Let's assume that. I'm just going to keep this for another time. If lines are not parallel, let's assume that they meet at point P equal to x0, y0. Intersection point. This point I'm calling it x0, y0. Okay? Let me get rid of this. Then x equal to x minus x0, y equal to y minus y0. Turns problem into is what f of some constant times capital X, some other constant. B or I'm just going to solve an example for this, but just let me try to give you the idea of what's happening. If you have this form, first we try to check if these lines are parallel or not. If they are not parallel, then we are just going to find their intersection point and then use this kind of change of variable to turn this problem into this kind of problem that we know how to solve. Okay? If they are parallel to each other, then what happens? If parallel, use z equal to ax plus by. I'm letting you, as a homework exercise or whatever you would like to, see why this works. If we have these two lines parallel to each other, how can we use this? Okay? Good? This is almost, I have written it not in a very artistic way, but it is the whole roadmap up, what first order ordinary differential equations. If you know this, you are going to be almost always able to solve first order differential equations. What you need to do is this. Identify the problem, if it is a first order differential equation or not, then ask you these questions. Is it separable or not? If it is separable, then you know how to solve it. If not, then check this. If not, check this. And sub-branches. If not, check exactness. If not, try to find some integrating factor. If not, try to see if the equation is linear or not. You may see, at the first look, you may see that the equation is linear. Or at the first look, you may see that the equation is exact. No problem, you can jump. But whenever you see some problem and you don't understand what is the structure of it, follow this step by step. Okay? And in some places it's going just clear. Anyhow, after this roadmap, I need to come back to the problem here and solve it. No.
Okay, let's assume that we know that 2 and 3 are defined. Then it is unsolvable.
What do you mean by unsolvable? If you are saying that I have an equation which there exists no answer for it, we have not yet talked about this. I'm keeping it to when the time that we are talking about numerical solutions. Because I talk about numerical solutions, Picard's existence and uniqueness theorem that will give us the necessary conditions such that it will say us that, okay, actually there exists a solution that you can look for it. If you can find it from analytical methods, use it. Otherwise, you need to use the numerical way to really find what is happening over there. If you mean this, yes, we have some theorems that gives us the necessary conditions for the existence of solutions. We are just going to talk about them. Not in detail, but we will talk about them. But the problem is this. Normally, they are always talking about the uniqueness and existence at the very beginning of the courses on differential equations or whatsoever. I have kept it to the end because you are engineers. You don't care about this kind of uniqueness and existence problems, not that much. And almost always in all of the applications that you will see, the conditions of those equations are already satisfied, and you can be sure that there exists a solution such that you can work with it. Okay? That is what I have been keeping it in order for you to see that, okay, you have seen this much of problems, this much of, in all of them, the solution exists, so don't worry about it. Anyhow, let me check the time. Okay, I don't have much. Is this clear, is this roadmap? Okay, let me clear. Solve this one and then we can finish up. First of all, what was our problem? Y prime was equal to x plus y minus 4. Can you please remind me that?
Plus 6, 8 minus 6,
Minus 6.
minus?
Was it plus, minus?
Yes, plus.
It doesn't matter actually, but since we have worked that, I know the point where they are cutting each other and so on. That's why I'm insisting that it should be the same problem. Anyhow, can you please draw the line x plus y plus 4 equal to 0, and the line x minus y minus 6 equal to 0. Can you please draw these two lines and find the point of their intersection? But really first try to draw the lines, because it is important. I'm going to just give you some explanation. It is better to have the geometrical. What is the point x plus, what is the line x plus y plus 4 equal to 0? So, can I copy your image and pretty much? It is looking something like this and something like this. Okay, thank you. And what is this point of intersection? 1 and minus 1. Okay, let's do this. That change of variable that we had. If we have x equal to x minus what? 1. Y equal to capital Y equal to y minus 5. Or capital X is equal to x minus 1. Y is equal to y plus 5. Okay? What I'm trying to do is this. I'm trying to introduce a new coordinate system such that the origin of that coordinate system, capital X, capital Y. Okay, I'm trying to transfer the problem into a new coordinate system such that the origin of that new coordinate system, capital X, capital Y, is exactly at the intersection of these 2 points. What is this 4? What is this minus 6 or this kind? These are the intercepts, right, that the line has with the x-axis and y-axis, okay? If the intersection of a line with the x-axis and y-axis is going to be exactly at the origin, then what is happening? Then we do not have y-intercept, x-intercept, okay? They're equal to 0. Which means that in this new coordinate system, my lines are passing through origin, right? You see? This is exactly the idea that we need to develop. Look at this. How can I turn this problem from this small x, small y coordinate system into capital X, capital Y coordinate system? By this linear transformation that we have had, okay? First of all, I need to work with the left-hand side of that equation, y small prime. If we do this kind of a change of a variable, what is y small prime? Can I say that it is equal to capital Y's prime? Just take derivative of both hand sides. What about the right-hand side? This is my old coordinate system. Capital X is my new coordinate system, and I'm trying to turn everything into this new coordinate system. So instead of using small x, what should I write? Small x is capital X plus 1. Small y is capital Y minus 5. Okay? So what I need to write here is that x, I need to write plus 1 plus y minus 5 plus 4 divided by what? Instead of small x, again, x plus 1 minus, instead of small y, y minus 5 minus 6. Now look at this. What do we have here?
Well, the constants are gone now.
Constants are 0.
Yeah, it becomes, yeah.
And constants, yeah. Coefficients were, but look at this. This change of variable. We have manipulated everything in such a way that this number plus this number is going to be minus of this number. So you look at them, they're going to cancel each out, right? So this is going to be x plus y. What about this one? Again, this is 1 plus 5, which is 6 minus 6, 0. So we have again x minus 1. Now look at this. What do we have? So, what has happened? By using a new coordinate system, we have been able to transfer this problem into what? A problem that we had been able to solve it before, right? Can you please solve this differential equation? Yes, you definitely can solve it. We have just solved it. Okay? Then what will happen? When you solve this equation, then you are going to get something with respect to capital X and capital Y. You remember the answer for the question before. It was, I think it was going to be arctangent of z minus 1 over 2 ln of 1 plus z to the power of 2 was ln of x plus c. And this is the capital X actually. I think it is going to be looking like this for y divided by x. This is exactly the same integral that we had, right? Integral of 1 minus z divided by 1 plus z to the power of 2. Yeah. I'm just calculating that integral on the right hand side. Instead of z, what should we write? Capital Y divided by capital X. Capital Y divided by capital X. Okay. Are we done? No, we're still not done. Because our problem is small x and small y's. So what we need to do yes, we translate everything. I think I also write capital A. This has some, we need to arctangent of, what is our y, capital Y? Yes. Y plus 5, x minus 1. Minus 1 over 2 ln of 1 plus y plus 5 x minus 1 to the power of 2 equal to ln of, let me also write the absolute value because I'm not sure about it. So it is going to be x minus 1 plus c. Finally, we are done. Is this clear what happened? We have turned the problem into a simpler problem that we know without intercepts. Then we turned it into a function homogeneous. We know how to solve it by using change of variable z equal to y by the x. And so on and so on and so on. And after solving, we just replace everything back. Okay? Good. Do you have any further questions? We are almost done with 2 first chapters of our book. Okay? From the next week that we are going to have we are going to talk about numerical solutions, about uniqueness and existence theorems, and we will start talking about second order differential equations. Fine? So the book of first order differential equations is going to be done with it. We are going to come back to this kind of materials as well, but for now it is done.